Hey guys, welcome back. So today I brought home two Predator generators. I found these on Facebook Marketplace. They were listed at $60 each. And for 60 bucks, you can't expect much. These, of course, don't run. And the person selling them didn't really know much about it because he purchased a house and these were in the yard. Neither one runs. The one on the right, when I pulled it over, the engine spun maybe half a turn and got stuck. And the one on the left turns freely. I don't think we have any compression there. To make matters worse, this house is off grid. So these generators were used quite a bit. I'm sure the engines have thousands of hours on them. And as if that wasn't enough, when unloading the generator from my car, this fell onto the ground. And this looks to be an outer race of a ball bearing, the type that would hold a rotor in place on the end housing. So I don't know if this is from these generators, but yeah, I think we need to find out before trying to get either one of these started. So I'm going to roll the one on the right out of the way. That's the one with the stuck engine. I'm going to get the end cover off this generator, make sure it has a ball bearing, and go from there. It's pretty hard to tell, but I think we're okay. It looks like I do see the seal for the ball bearing. The ball bearing itself is pretty well hidden with the end housing and this washer kind of in the way, but I don't see any signs of damage, and the rotor bolt looks reasonably centered, so I think we're okay on this one. So I'm going to get the spark plug out, get the compression tester in, and see where we're starting at. A lot of oil. Interesting. I'm going to blow that out. It's just full of junk. Spark plug's tight, so it's a little concerning, actually, that there's so much oil in this area. So it could be maybe a blown head gasket. I'm not sure. Here's just a closer look at the spark plug. You can see all the oil on the insulator, something going on here, potentially blowing by the washer, and the plug doesn't look great. It's a little white on the tip, so it may have been running a little lean when it was last running. Let's give this a try. Ideally, we'd see about 60 psi. This has a compression release, so it's not going to be much higher than that. And we get absolutely nothing. So I think the connecting rod is probably blown on this engine based on how freely it turns. So yeah, let's get the tester out, take a peek down in the cylinder, see if that piston's moving. Just going to use a screwdriver insert it into the cylinder until it hits the top of the piston, which is right there, and pull the engine over. If the connecting rod's not blown, that screwdriver should go up and down with the piston. But in this case, it's not moving. So yeah, unfortunately, the connecting rod's blown. So this engine is done, but for 60 bucks, can't expect much. Most likely the power head is good, the tank is good, and a lot of the other things connected to the engine. So let's roll this one out of the way, pull that one out, and see if that one has any chance. Let's start by checking this ball bearing. Yeah, looks fine. So no issues there. Let's maybe get a wrench on that, see if we can back the engine up. So when looking at the engine this way, the normal rotation is counterclockwise, and that's where it's stuck right now. I'm going to apply a little bit of pressure, and it doesn't move. Let's try it backing the engine up. And it is moving. It does not sound good though. There's definitely metal on metal. Now it's not moving again, so yeah, maybe we have two bad engines. Yeah, and now it's stuck. So yeah, let's pull the spark plug out of this one, see if it's the same problem. I just backed the engine up all the way until it stopped turning. So do the same thing. The piston's actually right near the top, and that's where it's stuck. Pull the engine over, and we got movement. So the connecting rod on this one is not blown. You know why it's getting stuck at the top? Potentially it's valves or maybe some junk in the cylinder. And what that noise is, yeah, not sure. So I'm going to spray a bunch of PB Blaster down there, rotate the engine a little more, see if it can't make it past top dead center. Nope. So whatever's hanging the engine, I don't think it's in the cylinder. You know, potentially something in the power head, maybe a stuck valve. So I'm going to get the valve cover off and see if there's anything suspicious under there. Nothing too suspicious here. Valves are not stuck. So I'm going to rotate the engine, just see if either of these move. Huh. Oh. Made some unexpected progress. The engine, it now rotates all the way around, and both the valves are moving, and of course the piston is going up and down. So it's looking promising, although it is still making quite a racket from somewhere, either in the engine or the power head. So I'm going to throw the compression tester on there, see if this engine has any compression. $40. It's low. Should be 60, but better than 0. So this one I'd say has potential, but it is making a lot of noise, and it's kind of hard to tell where it's coming from, but I think it might be the engine, which has me confused because I know the camshaft is good, the valves are moving, and the connecting rod seems to be good because that piston's going up and down. So I'm not really sure where that noise is coming from. So I'm going to look around, see if I can find anything. Sounds like the noise is coming from the starter recoil, like maybe the cup. I'm not sure. You know, when standing on that side, I thought it might be coming from the fan on the rotor, but now that I'm over here, it seems more on this side of the engine. Or it might be that. There's a big crack right there. And that part of the engine is ready to just fall right off. So that is interesting because the connecting rod, it's not blown. Camshaft seems to work. So I'm not exactly sure what would have damaged the block like it is, but the block, unfortunately, it is junk. You know, this one, I know the connecting rod is junk, but the block seems to be good, at least on this side. Let's check the other. Yeah, don't see any issues with the block on the outside, but with the blown connecting rod, there's a good chance it did some damage on the inside, but there's no way to know until I take these apart. So yeah, both of these need to be fully disassembled, sized up internally, and if I'm lucky, I'll have enough parts to make one good engine. I'm going to start by just getting the fuel out of the tanks. We'll get the tanks out of the way. We'll start peeling off the layers and eventually get both of these engines open and size up what I have to work with. Anyway, you get the idea. It's going to take a while to get both these tanks empty, but so far so good. I don't see any water in any of the fuel, which is surprising because these were stored outside, and the fuel coming out of the one with the crack in the block looks actually better than the fuel I bought last week from the gas station. You know, this stuff, it's past its prime, but it's not bad yet. So that can be used, but definitely sooner than later. 45 minutes later, and we're finally drained. Both tanks, they are empty, and I ended up pulling about 6 gallons out. This container here is full, and we got a solid, I'd say, gallon in this one. So not too bad. About $30 of fuel came out of these two. Wow, look at this tank. It looks like it was on fire, or at least something underneath it was on fire. The side of the tank that looks the most burnt actually would have been the side where the power head was, not the engine. So that is a little suspicious. You know, I do see more evidence of it on top of the engine. Right here, there's a lot of soot and a little bit there as well. So potentially it was an exhaust leak and not a fire. You know, I'm not seeing any melted plastic, so, you know, maybe we're okay and this wasn't exposed to excessive heat, because if it was, the insulation could have been damaged on that power head, and that would be unfortunate because those power heads, they are worth quite a bit of money. So as bad as this seems to be, I think there's a much bigger problem. This is the one with the blown connecting rod. We looked at each side of the block, seemed good, but now that the tank is off, I can see we have a major issue here. There is a massive hole on the top of this engine. You can see the crankshaft there, and I actually see light coming through from the bottom of the engine. So this block is done. Neither one of these engines can be rebuilt. They are purely parts engines. So we'll harvest some parts off of there. We'll check the health of these power heads, see if they're good and worth saving. And I might have an option. I do have a genuine Honda GX390 that has a compatible tapered shaft with these power heads. I think the issue is the bell housing is the wrong size, and these bell housings are actually integrated with the engine block. So that is an issue, but potentially we could get around that. So regardless, these have to come apart, and then we'll kind of size up what's feasible, if anything, with that Honda GX390. I'm going to start by testing the health of both these power heads. So I'm going to get the wires disconnected, get the multimeter out and run some tests. And while I'm here, I'm just going to get the hardware out for the exhaust. I'm just going to do a low voltage ohms test to check the health of this power head. So these are the main windings coming out, leg 1, leg 2. We'll test those in a minute. Resistance should be around 0.3 or 0.4 ohms. Up here is the input to the AVR. These blue wires, that's the DPE winding. That's what supplies power to the AVR. And this white and looks like gray is the sense winding. It's tied in to one of the main windings, and that's what the AVR uses to sense the voltage. And down here, there's two auxiliary windings here. One of them is to charge the battery. This is electric start. And the other one is to power the fuel solenoid. So these aren't critical. I'll check them anyway. And of course, we'll check the rotor at the slip rings and see what that comes in at. So we'll start with leg 1. Should be around 0.4, 0.3. And it is. Check it to ground. No connection. Leg 2 should be about the same. 0.3, 0.2. A little bit lower. Let's double check this one. 0.2. Yeah, so they're consistent. We'll check it to ground. We seem to be good. Let's check the DPE winding, which is the blue wires. That's usually around 0.5 ohms. Sorry, 1.5. In this case, it's 1.2, 1.1, so that should be fine. We'll check it to ground. No issues there. And let's check this auxiliary winding. I don't know what the resistance should be on this. 0.2, 0.3 seems reasonable. No connection to ground. And we'll do the same thing on this one. There's actually 3 wires, so it's probably center tapped. So we get 0.5 between the 2 brown wires, between a brown and a black, 0.3, which is half the value. So yeah, it's center tapped. And let's check it to the other brown wire. Should be about the same, 0.2, 0.3. Check it to ground. So things are looking pretty good. Let's check the rotor on the slip rings. Usually it's between 40 and 70 ohms. Usually I see close to 50, maybe 55. Yeah, perfect. I saw 49 for a second. So the slip rings, they're dirty, but looks like the rotor is good. Let's check it to ground. And that is not great. I wouldn't say it's a complete failure. It should work. But there is a connection to ground on the rotor in the 7 million ohm range. So I can double check that with the Megger. It should work, but yeah, it's not ideal. And let's just check each coil against adjacent coils. There should be no connection. So we'll do DPE to sense. No connection to leg 1, leg 2. And the auxiliary windings, no connection. So looks like DPE is good. Sense winding, there will be a connection, I think, to one of the legs, which is normal. Yeah, and there's a connection on there. So that seems to be fine. Check leg 1 to leg 2, no issues. and leg 2. So stator actually seems to be in very good shape. The rotor, not great, but it's a pretty high resistance. So I think this power head is usable. Let's check the health of this one. Let's do the same tests here. Check leg 1, should be around 0.2, 0.3. And we're at 0.3, so this one's a little, oh, there we go, 0.2. Seems good. Let's check it to ground. No connection. Check leg 2. Should get the same. We're at 0.3. 0.2. No connection to ground. So leg 1, leg 2 seem to be good. Let's check the DPE winding. We got, I think, 1.1 ohms on the other generator. And this one's higher, but I think we're within range. Usually it's around 1.5 plus or minus. So I think we're okay there. No connection to ground. And the sense winding should be the same as one of the legs, which is 0.2, 0.1. And I'm getting nothing. Let's back probe it just to make sure. Yeah, we get nothing on the sense winding. So without the sense winding, the AVR would have been running at full power and putting out about 170 volts. So yeah, most likely the stator is bad, but let's keep going. We'll check this winding. The other generator, I think it was about 0.2. And that's what we get over here. Let's check it to ground. Seems to be good. And this center tapped winding between the browns, I think we got about 0.6 ohms. That's what we get here. And from the center tap to one of the sides, it was about half that, which is what we get. Let's check it to ground. No issues there. So the big problem with the stator is the sense winding. We need that winding in order for this to work properly. And the fact that it's bad, you know, the generator's going to put out too much power. And even if I bypassed that and connected the sense right to one of the legs, you know, the fact is there's a bad winding in here, and most likely it's going to take out the others as well. But let's just double check the sense winding to the main legs, because if there is a break, one of them might still be connected. We have a pretty high connection there. That's better. Let's check the other wire on the sense. Interesting. The sense winding may not be bad. It looks like one wire goes to one leg and the other wire on the other sense goes to the other leg. So that is kind of interesting. So it's actually monitoring the 240 volt output, which they usually don't. Usually they monitor one of the legs, the 120. So yeah, I take back what I said. This sense winding actually might be good. Now let's check the rotor, see if this rotor is any better. There we go. Slip rings are pretty dirty, but we're kind of in the 53 ohm range, so that should be fine. Let's check it to ground. And same on this one as the other one. There is a high connection to ground, about 7.5 million ohms. And that's not ideal, but it will work. Kind of odd how this one's wired. I haven't seen it, but I suppose it is better that it's actually monitoring the output, the combined output of leg 1 and leg 2, but it made me wonder, why is this one different? And I just reviewed the footage and I realized that I never tested the sense on this one. So I just tested it and it's actually wired exactly the same way. One wire going to leg 1 and the other to leg 2. So yeah, both of these stators, they're good. In case you're wondering, that's 6 gallons of fuel. It is now in my car. That's usually how I get rid of old fuel. I've never had an issue with it. As long as it goes through the coffee filter without clogging and there's no water in the fuel, you know, mixing it with fresh stuff in the car tank, I've had no issues with. Anyway, I am on my way to get another generator. It's from the same guy that I got the first 2 Predators from. He was actually selling 3, and I can only fit 2 in my car, so I chose the better 2 of the 3. So I'm not expecting this one to be any better. Like the others, this engine has no compression, so most likely the engine is parts, but $60 for a good power head, it's well worth the drive. The third generator, it is in the back, and in case you're wondering, this is the house that they all came from. Technically, it was not supposed to be off-grid. About 5 years ago, some tornadoes came through the area, and the poles on the prior owner's property broke. And I assume he just didn't have the money to fix them, so he lived off-grid on generator power for 5 years. Yeah, don't ask. There is a better road, an actual driveway, but it's kind of washed out, so this is what I was told to do. I made it home with the third installment here of the Predator generator series, and I was gonna not record triaging this unit. I fully expect it to be like the others, but I just pulled it over and it feels decent. It's not freewheeling like the one with the blown rod, and I think I hear the piston moving up and down, and I looked over the block pretty well. Haven't found any issues with it. No cracks, no missing pieces. So this one has potential. There is, I'd say, very little to no compression. And the other thing I noticed is that the oil light comes on when I pull the engine over. So yeah, let's check the oil first and yeah, see if we have any. Actually, I'm just gonna pull it over right now so you can hear what the engine sounds like and also see that little oil light light up. So it sounds decent. It does almost feel like there's some compression there, but I did hear and kind of feel a strange clunk when pulling it over. I'm not sure the microphone's really going to pick it up, but it does sound a little strange. You know, potentially it just needs oil. Hey, the power just went out. Oh, it's back on. Anyway, we are low on oil. There is very little oil in there. So I guess my question is, where did the oil go? I'm not sure, but I'm going to add some more in there just in case it wants to start. Good. One problem down. Let's check the compression. The compression feels like it came up after adding the oil. So I don't think it's zero anymore. Doesn't look too bad. Not bad. We're at 50 psi. So a little low. It would be ideally at 60, but 50 should start the engine, and there is a compression release. So once the engine does start, the compression's only going to get higher. So let's get this tester out. Going to hook up the spark tester, see if we have spark. Not too bad. We've got spark. We've got compression. Do we have fuel? I would say most likely not. Let's just double check the spark. Make sure the plug is sparking. Yep, good consistent spark on that plug. So I say we try starting it. But first, I'm going to pull the cover off that power head. Just make sure the ball bearing looks good and that there's no concerns going on in there, because this engine, it's looking like it's going to run. So yeah, maybe we have a problem in the power head. Well, besides the dirt, it looks decent in here. I can see the ball bearing is present. I don't see any obvious damage, and you can just get a glimpse of the stator down there. The copper color looks good, the lacing's intact, and the glimpses that I can see going around all look good as well. So I say, let's just turn the fuel valve on, choke the engine, see if it starts. Got the light plugged in and turned on, as well as the kilowatt on standby. So the fuel on, choke on, and that throttle's not stuck. So let's see what happens. That kind of surprised me. It started right up once I turned that switch to on, and the light, it came on. The engine sounded good, but the light only stayed on for a second. I heard something pop. I assume that light burned out, whether it was its time to burn out or maybe there's too much voltage coming out. So I'm going to replace the light. I'll hook up the voltmeter and we'll try starting it again. All right, not too bad. 118 volts out on this outlet right here on the left. The one on the right, I had no power out, but I think I know why. These circuit breakers, none of them are tripped, but I just realized we have a GFCI breaker right here, and that's most likely what popped. I did not try to reset it, and I'm probably not going to, because when these fail, they trip and you can't reset them. And the fact that it tripped with just a light bulb on it tells me that, yeah, this outlet probably does have an issue, which is fine because I have plenty more to choose from. And if you look close at the grounding prong, I noticed there's something in there actually moving around. You can see it actually on the top right prong. I think I saw it on the top left, and I see it in the ground. See that? So, yeah, I think he's a little bit upset that I disturbed his home, and most likely he trashed this outlet. So we can test it here instead. There is no GFCI outlet here, and I don't see any ants. or critters, bugs. Oh, I take that back. There's one right there. So yeah, there's probably a bunch of ants just living in this control panel. But what do you expect? It was left outside. It was sitting in the mud. And all things considered, I mean, I didn't give this one much hope. That's why I brought these two home and left that one. Anyway, let's plug in a breakout cord and just make sure I have output on each of the legs. Okay, good. Both leg 1 and leg 2, they are making power. So the issue, it is confined to that GFCI outlet on the right. Now, the smoking, it's pretty bad. And given how low that oil was, I have a feeling it's not going to just burn off. We most likely have an issue with the rings. But let's give it the benefit of the doubt. We'll get it outside, run it for a while. And while we're at it, we'll do a load test. See if the engine is down on power. Actually, it's getting pretty late out, so I'm going to roll this to the side and finish kind of when I started over here, breaking these down, starting with the one that has the hole in the top, because I put my compression tester kit on top of that machine, and of course it dumped over, and I lost a few pieces into that engine. That's interesting. That head did not want to let go, but it finally did, and it came off in one piece. So this potentially could be cleaned up and reused at some point, assuming the valves weren't bent. And I don't think they were. If you look at the piston, I don't see any visible signs of impact, but there is a lot of carbon. I'd say this one was burning quite a bit of oil as well. And you can tell the head gasket was blown. The exhaust was coming out the side of the head. So this would have been down on power when it was running. The ball bearing, it's not releasing from the end housing. So I could easily put more pressure on this, but I think if I go much more, I am going to break the end housing, and it might come to that anyway if I can't get it to release. But I guess for now, I've sprayed some PB Blaster in there, give it a few minutes to work, and I'm going to get these mounts out of the way. It should help a little bit with freeing the stator off that bell housing. And that is supposed to be the easy one. Usually stators come off without much of a fight. It's the rotor that you have to worry about. In this case, because this machine was left outside, there was a lot of rust that formed on the outer race of the ball bearing, and just some rust jacking was holding things in place. So I'm not sure how I didn't break that end housing, but somehow it released. So to get the rotor off, I'm just going to remove this bolt inside. It should be threaded with an M12 1.75, and I'm going to tilt the generator up, probably at about a 45-degree angle or a little more, and fill the shaft with water and put some Teflon on the bolt and build some hydraulic pressure and hopefully pop that rotor off. Nope. It's not building pressure, so need more Teflon. That actually wasn't too bad. It took a few attempts to build pressure, and every time I do this, I always think I've put way too much Teflon on, and I'm proven wrong every time. You need quite a bit to form a good enough seal to build the pressure. Anyway, there's not much left now. There's only 2 bolts holding the engine onto the frame, and then I can open the engine up and just check out all the damage. So I'm actually going to pause it here. I'm going to repeat the same process over here, and I'll turn you back on when I am just about caught up and get both of these engines opened up. It's threatening to rain out, so I want to get this test in as soon as I can. The plan is to just start this up, let it warm up a bit, see how it does with the smoking, and then I'm going to apply a 3,000 watt load, see how it does, and then add another 2,000 watts to bring it close to the max, to see how it handles it, if it's down on power, and what it does with the smoke. This one surprised me. It actually stopped smoking, and I didn't expect that. So I'll let it cool down a bit, try it again. Potentially it's just an issue with the rings at startup, or maybe it just burned off and we're good to go. But as far as power goes, we were down on power, or at least I thought we were. I bumped the throttle plate, and I had no issues getting the engine back up to speed. So I think there's an issue with the governor system itself. I was taking a look at the adjustment screw to see if I could bring the no-load speed up, and it's maxed out. It's all the way in. So someone did that, obviously trying to compensate for something. And yeah, my best guess is that the spring that's on there is probably not the right spring for this engine. So yeah, not too bad. I think I'm gonna probably clean this up while it's out here and get it back inside. Well, that's interesting. The governor spring, it's attached to the inner hole here, and I've never seen that. It's almost 100% of the time on the outer one. So I'm going to back off this adjustment right here, move the spring, maybe just restart it real quick, see if that makes any difference. No, I don't think that's going to make a difference. I'm already halfway in, and there's almost no tension on there. So let me check real quick what I have for springs. Maybe I have one that'll work better. I found this spring here. Not sure what it came off of, but you can see it's quite a bit shorter. Maybe too short. And this is the one from the Predator I just took apart, the 420cc one. A little bit longer and see much heavier duty. So I'm not sure either one of these is appropriate, but let's give this one a shot. Yeah, that actually might do it. Let's try it out. Better, but still not quite right. Under a 3000 watt load, this time it held better at 57.5 Hertz, but it's not ideal. It should be closer to 59 Hertz under that kind of load, or even better. So yeah, I'll take a quick look online, see if I can find a better governor spring for this 302 Hemi Predator engine. But for now, I'm going to continue with the cleaning. I'm just going to get the cover on the power head and the airbox, wrap some plastic around the stator, and give this thing a power wash. This thing cleaned up really well. You'd almost never know that it was left outside, I'm sure, since the day it came home from the store. I temporarily just put this tank back on the generator to get all the old fuel out of the tank. Anyway, I've been doing a little research on this engine. This is a 302 Hemi Predator engine, and it's kind of a rare engine. I didn't find a whole lot, but I did see a few YouTube videos on a 301 Hemi engine, and on a couple of those I could see the governor spring. It looked just like the one I took off, and it was installed in the outer position on that governor arm. So I'm going to give this spring one more shot in the outer position and see if that makes a difference. So once this is done, I'll get it back outside and we'll give it one more try. The original spring, it is reinstalled. So we'll get the engine started. We'll set the engine speed back to 61.5 Hertz. And I also reset this GFCI outlet here. Potentially it was just one of those ants creating a ground fault. So the light is hooked up to that. So once we start the engine, I guess we'll keep an eye on that light, see if it stays on. Got smoke again. The ants aren't too happy about what's going on here, and neither am I. You know, it's marginally better with the spring in that position, but the engine, it can't maintain speed. The spring just can't overcome the force of the governor. So, yeah, the engine, it's not down on power. It did smoke again pretty bad at startup, and it's actually been a few days since the last time it started. So I'm guessing it might be a valve stem seal, just letting oil get in there when the engine is sitting. But yeah, I got to give this one some thought. I don't see any springs online specifically for this engine, so I might try a few others that I have and hopefully find one that works better than what's on there right now. I ended up calling Harbor Freight today to see if they had any parts for this engine, and they do sell parts for it. So I tried to get a set of rings, a valve stem seal, a seal kit, and of course the spring in question. Unfortunately, they didn't have any of that except for the spring. So I did place that order. It'll be here in about a week. So while I'm waiting for that, I'm just going to finish breaking down the two blown Predator engines. I'm going to start with this engine since part of my compression tester is in there, but before I do that, I want to talk about the governor real quick. I think this confuses a lot of people, and it's a bit of a mystery how this works. But quite simply, this governor arm, it's attached to your carburetor. And in one position, it's idle, and in the other position, it's wide open throttle. So what controls the balance and keeps your engine at a constant speed? Well, there's two parts to that. First, it's the spring, which I've been fighting with on the other engine, and its job is to basically hold the throttle open at wide open throttle. So if this was the only component, the engine would run at wide open throttle until it blows up. The other component is actually inside the engine. You can just see the gear right there. There's a shaft going down, and at the end of that shaft is a plate. And that plate is touching the governor. The governor just spins with the engine, and the faster the engine spins, the harder it pushes these weights out, and it pushes this up as the weights come out. So this is a variable force, and this is trying to slow the engine down. So at some point, when the engine's spinning fast enough, it overcomes the spring tension holding the throttle open, and it's able to start to close the throttle plate, which slows the engine, and then an equilibrium is reached, and that's where it sits until something happens, like a load is put on the engine. When a load is put on the engine slows. The force trying to close the throttle plate is reduced because of the engine speed slowing down. But this spring, it's pulling at the same force. So that allows the throttle plate to open until the equilibrium is reached again. So that's why I think the spring is the problem on that other engine, because it has no issues slowing the engine down. But the spring, its job is to speed it up when the governor lets off its force. Anyway, I hope that made some sense. Let's get this engine open. Yeah, this engine's a mess. I was hoping this cover was still good, but it is damaged here. There's supposed to be a ball bearing held in place because I have a Honda engine that might be able to repower one of those Predators with the blown engines, but it has a different bell housing. So I actually need the end housing from one of these engines to make that work. So unfortunately, this one is not going to be the one, but you can see it's a mess in here. We've got the ball bearing, the counterbalancer. The counterbalancer broke, and that's what led to this engine failure. Now this is the one, no, has a blown connecting rod too. It must be the other one that has the good connecting rod. But let's see here. We got the other half of the balancer. Piece to my compression tester. I'll keep that. Connecting rod. Oil sensor is blown apart. Camshaft is damaged. The compression release, unfortunately, got destroyed. So it's not looking like much is salvageable in here. So far, everything I pull out is destroyed. I know the crank is bad. I can see the rust and all the aluminum transfer. Let's see if we can get it out. Yeah, it's not terrible, but the skirt doesn't look great right there. So I wouldn't want to reuse it, but it stayed together. I'll give it that. The rings aren't stuck. But yeah, this engine's pretty bad. Let's take a look at the cylinder. Not that it matters, the case is destroyed. The cylinder actually looks pretty good. It's surprising. So the cylinder is decent, but of course the entire crankcase is destroyed. The piston, I mean, it's not great, but it's not terrible. So I don't think the piston seized in the cylinder. That is not what caused the issue. Either this let go and took out the connecting rod, or more likely, given the aluminum transfer, I'd say that the connecting rod seized on the crankshaft and that snapped. And when that happened, it took out the counterbalancer. Anyway, there's not really anything on here I can save, except maybe the starter and maybe the governor gear. It actually seems to be intact. But that is pretty much it. So let's take a look at the other engine. Bummer. Looks like this cover is junk as well. We're missing a big chunk there, as well as the part here that holds, I think it was the counterbalancer. Yeah, actually the counterbalancer is missing. It's supposed to be right there. That's interesting. It must have gone out the bottom. I didn't even notice this before. But there's a huge hole on the bottom when this thing let go. Interesting. Camshaft has a few nicks on the lobes, but probably usable. Let's get the connecting rod detached. And see, the connecting rod did take a little damage here. Is that a plant? Huh. My camera stopped recording for some reason, but you didn't miss much. I just pulled the cap off, and yeah, it doesn't look great. The bolt on the other side came out really well without much effort, but this one did not. So something, I'm sure, got damaged on that side where it took the hit. And even though the connecting rod's not broken, it probably should not be reused. So let's get the piston out, and then we'll pull that crankshaft out. It doesn't look great. You can feel all those scratches, but nothing's broken. It somehow survived. But yeah, not in great shape. Let's take a look at the journal. Yeah, not great. And the crankshaft, I'm willing to bet, looks decent. Yeah, it's not bad. Ball bearing's good. Journal needs to be cleaned up a bit, but looks good. And the gears look good too. A little surface rust, but not too bad. So I'd say the crankshaft is good on this engine, as well as the camshaft. The cylinder looks good too. So, yeah, this one, unfortunately, can't be saved due to the fact this is a giant hole in the bottom. But we did get a few good parts out of this one. So, yeah, let me pause it here, and I'll turn you back on in a second when I get that spring from Harbor Freight. I decided to test this oil switch because it looks physically in good shape, but the oil did smell kind of burned. So there is a metal terminal right here coming from the sensor, which goes up here to where it bolts to the engine. So that's where it would pick up a ground. And of course the yellow wire, that's what goes into the low oil module and looks for a ground from this switch. And like this, with no oil, we should have some sort of connection, but there's no connection. So this oil sensor is definitely bad. And that's all I took from those engine blocks. There really wasn't much worth saving, but these starters, they are worth a decent amount of money. Not to mention we have a bunch of other good parts, including the fuel tanks and the generator heads. And actually, while shooting this video, I've already stolen parts from these two Predators to save 3 other generators. I had to use the fuel tank to save one that was rusted out. I stole the starter recoil to get another generator going, and I also stole the pushrod guide from one of the heads to save another engine that had a worn pushrod guide. So yeah, not too bad. The new spring showed up from Harbor Freight, and it looks exactly like the one that's on that engine. So I'm not so sure that this is going to make a difference, but it might. So I'll give it a try. I'm actually going to install it on the inner hole as it originally was, and we'll try to get the engine up to speed with this new spring. And if we do, we'll see how it does under load. So let's double check the diameter of the wire on the old spring. It's about 0.8 millimeters. Same on the new. 6.7 millimeters on the coil. And same on the old. So, yeah, the new spring looks to be the same. Okay, well, I can't argue with that result. The new spring, it is definitely doing a better job. Granted, I didn't test the old spring in this inner position, so that could be part of it. Also, I bumped the engine speed up higher than I normally do without a load. I brought it to about 62 to 62.5 hertz without a load, and a lot of manufacturers recommend that. I prefer to keep it as low as possible, but on this generator, I can't do that. So I brought it up to 62, I think 0.2 hertz, loaded it to 5,000 watts, and it held right at 57 hertz, which isn't great, but it's not terrible. The total droop is just over 5 hertz, and usually between 4 and 5 is considered acceptable, and anything over 6 I think is an issue. And before, we were getting a droop of 8 hertz. So I think this is now passable. Really, the only issue left here is the smoking. And I wouldn't say it's a big issue because it only smokes like crazy for about 30 seconds after startup, and then it burns off. And I don't really smell smoke after that, like oil burning. So I'm thinking it's a valve stem seal. Maybe it's bad rings. I'm not sure, but a valve stem seal is an easy place to start. So when the engine cools down, I'll get the valve cover off and take a closer look. Going to try to get this valve cover off. I want to take a look at the valve stem seal, especially on the intake valve. Now, Harbor Freight does not sell the seal, and I haven't been able to find it anywhere online, but I'm hoping that it's the same as a Honda GX 390. So we'll get these bolts out, get the cover off, take a look. But these bolts, they do make me nervous. They're pretty small. Let's give it a try. These rockers are massive. Haven't seen anything like this before. So it's probably not a clone of a GX 390. Just going to rotate the engine over. I'm going to check the clearance real quick. The intake's really tight. And there's a bit more clearance on the exhaust, but both the valves are tight. I don't have specs on these, but I'd say this one is very close to 0. And yeah, this one's not too far behind, but we'll worry about that later. I'm going to see if I can get this rocker uninstalled and then go from there. Well, that didn't do anything. Take that back. It was holding the pin in. Yeah, it's hard to tell. I can see the valve stem seal, but it doesn't quite look like what I'd expect for a GX 390 clone, which this is not. This is a 301 cc Hemi engine, so it is very different, as you can tell by the rockers. So I'm leaning towards not taking the head off and taking the spring off just to find out that a GX 390 seal is not compatible. So I'm going to take another look online and see if I can get any more information. But if I can't, then I'm leaning towards leaving good enough alone. Yeah, I double checked. I can't find anything online with a positive ID on what valve stem seal is needed. So I think I'm going to leave good enough alone. You know, this engine has a ton of hours on it, and I'm not sure it's worth a rebuild anyway. The smoking may not be the valve stem seal. It could be something like the rings, and I don't think this one is worth rebuilding. So I'm going to set the valve clearance. I did find the specs on that. Each valve should be between 4 and 6 thousandths of an inch. So I'm going to get this rocker reinstalled and hopefully not lose the rotator cap in the process. Don't have a spec on this. I'm going to go to 80 inch-pounds. Most engines call for 100. We'll do 100. So let's see where we're at. Start with the 4 thousandths. Does not fit. That's the minimum spec. Let's try 2 thousandths. Yeah, 2 thousandths fits. Ton of drag though, and it's got my feeler gauge. There we go. So I'm going to crack these loose. I'm going to use the impact for that. These are usually on there pretty snug, but the impact will shock it right off. Actually, I'm going to set it to 5. That's right in between. Should be between 4 and 6. That feels good. Exhaust is good, actually. It's right at 5 thousandths. Well, guys, that's pretty much a wrap. 3 Predator generators in one video is a lot to handle, but we got through it, and I was a little bit bummed to start with. I thought for sure one of those first 2 would be a survivor, and it turned out those were only parts machines. And I mentioned a little while ago that those had already saved 3 other generators while shooting this video. Well, last night, it just saved a 4th. I brought home this Honeywell generator, and it was not making power, so I took one of those Predator power heads and bolted it right on, and now this one is a survivor as well. Anyway, this thing, I'd like it to be perfect, but in the end, it was a $60 generator, spent a few extra dollars on the spring, and everything is working well on it now. Granted, the smoking issue, it's still there, but it's only at startup, and I think this will make a good generator for someone in an emergency. And I'm not going to ask much for it based on that condition, but I don't have much in it either. So I hope this video helps someone. Thanks for watching.